Chapter 9-6, Wind and Water Current Problems. This is where it's fun. This is where the rubber meets the road, shall they say. We can learn about all these things, we can replicate it, and we can sort of mimic the work, but the real test is when we get word problems. Can we take our knowledge and can we apply it to something that we're not familiar with, which tends to be word problems. So this is the great thing, and the more word problems that you tackle and you familiarize yourself with, the better you're going to be at it. Avoiding it is not the technique to get better at things. We tackle it, we struggle with it, we find out where we're making the mistakes, we try to find some form of pattern, because there will be a pattern to these problems. You just need to get experience using those patterns or finding those patterns and then applying it to these wind and water current problems. So we will take this. A jet can travel 6,000 kilometers distance between Washington, D.C. and London in 6 hours with the wind. The return trip against the same wind takes 7 hours and 30 minutes. Find the rate of the jet in still air and the rate of the wind. So the jet's going to go a certain amount. It's going to slow down because of that wind speed. So wind is either going to help it in one direction or hurt it in another direction. So we still are going to use distance equals rate times time, and that we'll find out that the distance is going to be the same. We know that the distance from Washington to London is going to be the same as London to Washington. So if we set up two equations that are equivalent, we can figure out the two pieces, and you'll notice how we do it. So let's get that started. So let's draw. I like drawing. We've got a small plane traveled the 1,200 kilometer distance between the two islands in 4 hour with the wind. The return trip against the same wind took 5 hours. Find the rate of the plane. So we've got an island. We've got an island. That's an interesting island, Mr. Mack. It looks like a cloud. Well, okay. Yep. And here's my interesting plane. Yep. And my plane, oh baby, whee, yes. So my plane is going to, hey, if this is what it takes. So this is island 2. So we know the distance between the two islands is 1,200 kilometers. Let's just draw it, right? We draw first. And so distance equals rate times time. We're going to have a distance towards, so we're going to have one going towards one island, and then we're going to have, let's make it in this direction, and then we're going to have going back that 1,200 kilometers, going back, returning from the island, and we have distance equals rate times time. So that distance is going to be the same, the rate of speed. So we'll say distance with the wind, and then we have distance against the wind. Okay, so we know what the time is, so let's start filling in the pieces. So it is 4 hours. So T is 4 hours with the wind. And it is going to be 5 hours against the wind, the same wind. So it's going to be 5 for here. So we know, I'm going to move this a little bit down. So this is against, this is with. We know that our rate of speed when it's with, so we know R, so D, whoops, so distance, we know our rate of speed is, we're going to gain speed with the wind. Our time is 4, so we know that that's going to be correct, right? We can substitute, we know what the distance is, it's always going to be that. And then we know on the return trip, we know that our distance is still going to be 1,200, but this time we know that our rate is going to be minus the wind. or the wind will take away our speed. When we go into it, we go slower. Hence why we would subtract the wind. And then we know our time going back is 5 hours. Okay, we're good with that? So here's the cool thing is we see that this equation is equal to 1200. This equation is also equal to 1200. So guess what we can do? Yes, we can write equivalencies for both of those, or we can write two statements. I like just setting them equal to each other. So I will have 4 times the quantity R plus W equals, oh no, maybe I don't like that. I think I'm going to write two statements because we would have two variables and that would not be okay. Well, we'll see. Let's do this. Let's take both of those equations. So let's do 1200 equals 4R plus 4W over 1200 equals 5R minus 5W. Now, if we use the addition, that's not going to work. So let's use multiplication. I'm going to multiply this by, let's do -5, and let's multiply this by 4. So let's do this. That's going to do the 1200. 1200 times 5 gives me 6,000. -6,000 equals -20R minus 20W. And then this is going to be 4,800 equals 20R minus 20W. That's going to give me 1200. My R's are going to cancel. I'm going to be left with -40W. Divide by -40. Divide by -40. The zeros cancel and we get, oh, that's -1200. Sorry, it's -6,000. So we get positive -30 equals the wind. So the wind speed is going to be 30. So what is the rate of the wind? The rate of the wind is 30 kilometers per hour. Wind speed is 30 kilometers per hour. And now if I want to find the rate of speed, I can take either of those equations. We'll take, let's do it in blue, 1200 equals R plus W times 4. So 1200 equals R plus 30 times 4. 1200 equals 4R plus 120 minus 120 minus 120. And that's going to give us 4R equals 1080. Divide by 4. And we get 270 equals the rate. So the speed of the plane in still air with no wind is 270 kilometers per hour. I like that. Those are the two answers. That's not bad at all. So the wind is helping in one direction and hurting in the other. So they want to know, find the rate of the plane in still air and the rate of the wind. Let's go back to the example and let's see how they did it the same way. Okay. Yeah. R plus 1. Oh, I see what they did. They got rid of that quantity outside. I get it. That's not a bad way. We can do it either way. It'll just be easier. But I don't remember doing it this way, but it worked. It's good. It's something. A plane traveled 2,000 80-kilometer distance between two cities in 5 hours with the wind. The return trip against the same wind took 6.5. So 2080 going that way, distance equals rate times time. Distance is 2080. The rate of speed we don't know, but it's with the wind, and the time with the wind is 5 hours. And then going backwards, going backwards, 2080 is going to be distance equals rate times time. We'll say the distance is 2080. This time it's rate minus W. It's going to slow it down, and that took 6.5 hours. So we'll do this other technique. We're going to divide. Let's divide by 5. This is kind of fun. Mr. Mac. Yeah, I know, I'm a nerd. I know. So 2080 is 416. 2080 divided by 5 is 416. So we get 416 equals R plus W. And then if we'll see if this divides cleanly. 6.5, 6.5, 2080 divided by 6.5, 320. So this is 320 equals R minus W. And the only reason is they're smaller numbers. So that's why I would contemplate doing this. 416 equals R plus W, 320 equals R minus W. And when we add them, we notice that the W's cancel naturally. I don't have to manipulate any further. So when we add them together, we get 63736 equals 2R. Divide by 2, divide by 2. You get 368 equals R. 8, 16, 612, 36. Yep. So that is the rate of speed of the plane. The plane in still air is traveling 368 kilometers per hour. Now, if we want to find the speed of the wind, we can take either of those equations. We'll take 320 equals R minus W. We'll plug in the rate of speed, 368 minus W minus 368 minus 368. And I think we get 48, negative 48 equals negative W multiplied by negative 1. We get 48 equals W. Does that, yeah, 68. Yep, that's good. So the wind is 48 kilometers per hour. That's that question. That's this question. And did we answer it? Find the rate of the plane in still air and the rate of the wind. Yep, nice. We're okay with these. A small plane can travel the 3,200 kilometer distance between two cities in 10 hour with the wind. So 320 km. Distance equals rate times time. Distance equals, we don't know the rate, but it's with the wind. We do know the time is 10 hours. So we start seeing the similarities between each of these problems. So we're good like that. Against the same wind, can only fly 20. Oh my, okay. Okay, that's okay. It doesn't fly the same amount of distance, but that's okay because we're not setting them equal to. We're just writing an equation, distance equals rate times time. The distance is still different. The rate is still minus the wind. The wind and the rate of speed are constant and or the same in both, and we just have a time, the time that is. So this still works. You can still do this. We're going to divide by 10. Actually, it works out because we get 240 equals rate minus W, and we get divide by 10, we get 320 equals rate plus W. So we still get two equations that are equivalent because they have the same variables. So let's take that. I think it's 320. 320 equals rate plus W. 240 equals rate minus W. We'll add them together. They cancel. We're left with 560 equals 2R. Divide by 2, and we get 280 equals the rate of speed of the plane. The plane, even if it travels a shorter distance, is still traveling at this speed. The plane is traveling 280 kilometers per hour in still air. And is that the question? Find the rate of the plane that's still and the rate of the wind. Then we can plug it back in for wind. So we can say the rate of wind is going to be 40. So we see that it goes 240 against the wind. So the rate of wind, the wind speed is 40 kilometers per hour because we just plug in the 280. So 240 equals 280 minus W minus 280 minus 280. Negative 40 equals negative W multiplied by negative 1. 40 equals W. Nice. Fun. Find the rate of the plane in still air and the rate of the wind. Same thing. A plane can fly 4,800 kilometers in 4 hours with the wind. Distance equals rate times time. 4,800 is the distance. The rate is with. That rate of speed includes the wind. That's why we add it to the R times the time, which is 4. Going back, same distance. They're going to return this time. The whole trip, the last plane didn't return completely. So distance equals rate times time. 4,800. This time, equals, this time it's the rate minus because that's going to slow. So it's going to slow your rate of speed. So you would minus the wind, and that takes 5 hours. So let's divide by 4. I really like this little addition. Rate plus W. That's one equation. Divide by 5. That is going to be 960 equals R minus W. Does that make sense? Yep. So we have 1,200 equals R plus W. We have 960 equals R minus W. Combine them. W's cancel naturally. We get 60. 2160 equals 2R. Divide by 2. Much more manageable. No calculators needed. I needed a calculator in the other one. Equals rate of speed. So the plane is traveling 1080 kilometers per hour in still air. And then we plug it back into our rate here, and we got 1080. So we can take this. 960 equals 1080 minus W minus 1080 minus 1080 and that's 120 equals the wind, negative, negative, multiplied by -1. 120 equals the wind. That is a heavy wind. The wind is blowing kilometers per hour. Yes. I think we change it up too. No, they're all wind problems? No, water. I think there's water coming. I think we're going to be in a boat. I'm on a boat. 4,200 kilometer trip from New York. New York. Technically, New York needs to be on the east side. San Francisco is on the west side. So from New York to San Francisco takes 7 hours flying against the wind. Oh, so we're going, I don't know if that's true. Is the wind, does it take? I don't know. Distance equals rate times time. Distance is 4,200. The rate minus the wind, because it's going to slow down your rate of speed, takes 7 hours. And then coming back home from San Fran to NYC. I know it says just New York, but distance equals rate times time. Distance is still 4,200. This time you're going with the wind, and it should take you less time. We'll divide by 7 because we know 7 goes into 4,200. 600 times R minus W, and we'll divide by 6. Divide by 6 gives us 700 equals R plus W. Let's write those together. 600 equals R minus W. 700 equals R plus W. Cancel the W's. 1,300 equals 2R, divide by 2, and we get 650 equals the rate of speed. The plane is traveling 650 kilometers per hour in still air, meaning unaffected by the wind. If there was no wind, that plane would be traveling 650 kilometers per hour. And let's use this one, yes. Let's use this one. Let's try this one. So 700 equals, what did we say, 650? 650 plus W, let's minus 650, minus 650, and we get 50 equals W. So the wind is 50 kilometers. Wind is 50 kilometers. Make sure we answer the question. Find the speed of the plane in still air and the wind speed. Yes, paddling with a current. Current is the same thing. You're going to have a speed that you are paddling. And then that current is either going to help you if you're going with the current or against you, which will slow your speed down if you're going against it. A canoeist can travel 48 kilometers in 3 hours with. So we just have to make sure that we understand that's a horrible canoe. That's my canoe. Let's make it more blunt because it's very new age. You know how those new ones are sort of like that. And then let's draw. Are we going to draw paddles? So we'll say this is the paddle. There's my paddle. Yes. And we'll say the current, whoa. The current is going that direction. So it's still distance equals rate times time. Distance equals rate times time. Let's put that underneath there. distance, so 48 kilometers. So this is 48 kilometers. Okay, so 48 kilometers equals the rate of speed plus, makes you faster. They can do it in 3 hours going with the current, and then distance against the current is still rate times time. Distance is still 48 kilometers. This time it's minus, and I think it took 4 hours. 4 hours to travel back against the current. That would be really exhausting. Let's divide by 3. And that is going to be 16 equals R plus W. Let's just move this down a little bit. And this one divided by 4. 12 equals R minus W is my other equation. We got 16 equals R plus W. 12 equals R minus W. Let's add those together. We get 28 equals 2R. Divide by 2, divide by 2. And 14 equals R. So you're paddling at 14. Paddling 14, is it still kilometers? Kilometers per hour. Wow. In still water. And then, if we want to find, I'm going to go back to this one. I found that that was a little bit easier. 14 plus W minus 14. So 2 equals the water speed, the current. The current is 2 kilometers per hour. That's not bad. It's paddling at 14 kilometers per hour. That's pretty fast, I think. A cabin cruiser. Ho-ho! Fancy schmancy. A cabin cruiser. Cabin cruiser has to have a couple decks. Maybe even a helipad. And we got the fishing lines going out. We got the steering cabinet up there. Yep. We got dual lines going out. Leaders, I think is what they call them. And then we got... He's going. He's going. Got to make it entertaining. Okay, there's my cabin cruiser traveling with the current. With the current means you're going to go faster. When 120 kilometers. So we got 120 kilometers. With the current, distance equals rate times time. The distance is 120. Rate of speed with the current. With is not the W, with is the plus. Took 3 hours. And then against the current, still 120 kilometers. Distance equals rate times time. Still 120 kilometers. This time it's going to be, the current will slow it down. Against the current, took 5 hours to travel the same distance. So that's the key word. Make sure that it's the same distance. 40 equals R plus W. And we divide by 5. And we have 24 equals R minus W. I get my 2 equations, nice and easy. 40 equals R plus W. 24 equals R minus W. So this is nice. You just have to, whoa, I don't want red. You just need to be able to remember the logic of setting up these equations. And that's all I relied upon. I went concrete, distance, rate, times. 32 equals the rate of speed of the cabin cruiser. The cabin cruiser travels 32 kilometers per hour in still water. And then we go back to here. What was it? 32? 32, 40 equals, we put the speed in there, minus 32, and then we solve for the current. So 8 equals W, which represents the current. So the current is 8 kilometers per hour. And that's important. This is a very realistic situation when we sail, when we paddle. I mean, you have to understand how other elements will affect your speed. A sailboat that's my sailboat. That's my sailboat. A sailboat travels 24 miles downstream in 3 hours. So downstream means with the current. So it's going to travel 24 miles. Hey, finally, distance equals rate times time. 24 equals with the current downstream takes 3 hours. The return trip upstream takes 4 hours. So distance equals rate times time. 24 equals rate minus 3 takes 4 hours. Let's do the shortcut technique. And that is going to be 8 equals R plus W. Let's move this stuff down. And then shortcut tells me to divide by 4. 6 equals R minus W. 8, I don't want it green, I want it back in black. 8 plus W. 6 equals R minus W. Let's add those. W's cancel. 14 equals 2R. Divide by 2. 7 equals the rate of speed. Well, sailboat is a little bit slower. Sailboat is traveling 7 kilometers per hour in still air. Can't be still air, because then the boat wouldn't go. Still water. I probably said still air in the other one. Still water. Still current. Did I say water? Still water. Still water. Good. Okay. Not still air, because a sailboat will not move in still air. See what I did there? 7. Wow. Okay. So 8 equals 7 plus W minus 7 minus 7. 1 equals W. So are we in the ocean? Downstream. The stream current, or you can just say the stream, is 1 kilometer per hour. Stream current is 1 kilometer per hour. Yeah, that's good. A crew can row 45 kilometers downstream in 3 hours, rowing against the same current. The crew rowed the same distance in 5 hours. Are we going to do a shell? Are we going to do a rowing shell? Boys in the boat. And then you got big old long paddles. And then we got a big old long paddle. Then we got a big old long paddle. And we got a big old long paddle. And we'll call this a five-person crew. Yep. So crew can row 45 kilometers. Oh, did I do miles per hour? I did not. That's miles per hour. Miles. Saw it? Remembered. Miles. Trying to trick me. I caught it. Miles per hour. Sorry. Now we're back to kilometers per hour. Kilometers per hour. Against the crew can roll downstream. So 45, so distance equals rate times time. 45 equals rate plus the current. Took them 3 hours coming back. That 45 kilometers. Distance equals rate times time. 45 equals rate minus the current. Took them 5 hours? 5 hours. We again like these because we can divide by 3. These are divisible. And that gives me 15 equals R plus W. And when we divide by 5 here, that gives me 9 equals R minus W. So 15 R plus 9 R minus, W's cancel. 24 equals 2R, divide by 2. 12 equals the rate of the crew boat, the scull boat. I don't know if it's called scull. Scull boat traveled 12 kilometers per hour in still water. And that was 12, so we'll use this one. 15 equals 12 plus W minus 12 minus 12. 3 equals the water speed. The water speed was 3 kilometers per hour. I think it was 3. Good. Was that the last one? Nope, but this is. The 3,600 kilometer trip between 2 cities takes 6 hours flying with the wind and 7.2 against the wind. Find the speed of the plane in still air and the wind speed. All right, nothing different. City 1, city 2. That distance is 36. Distance equals rate times time. 3,600 equals the rate plus the wind takes 6. And then distance equals rate times time to go back. Whoa. To go back. Still took 3,600, the same distance. Rate is minus, and it took 7.2, I think. What is the number? Let's divide by 6. That's easy. 600 equals rate plus wind or current. Divide by 7.2. 7.2. That one I may have to do. 3,600 divided by 7.2. 500. 500 equals R minus W. All right. Let's write those two equations next to each other. R plus W, 500. R minus W, 1100 equals 2R. The W's canceled. Divide by 2 gives you 550 equals the rate of speed. Are we doing kilometers or miles? Kilometers. 550 kilometers per hour. The wind is, what did we say, 550? So 600 equals 550 plus W minus 550 minus 550. 50 That's horrible. 50. 50 equals the wind. Wind is 50 kilometers per hour. Good. Hopefully you feel better and more confident about it. It's good problems. You're going to see these type of problems. That's what I love about this book, is that they really do present to you problems that you will see on assessments, on placement tests, on SATs, on HSPTs. These are very, very typical questions that are posed to students to show their mastery of Algebra 1. Good luck.